Okay, now, I wanted to get something on tape before, as soon as you took the Chapter 6 test. Does everybody, he's very loud with his computer, he loves his computer. Does everybody understand a little bit better that how important Chapter 6 is in order to be able to do Chapter 7 and 8? If you didn't do well on Chapter 6, the odds are you're not going to do well on Chapter 7 and 8. That's the bad news. The good news is you're going to have winter break to see if you can put together some understanding of Chapter 6 by utilizing some of the YouTube videos I made. I think I made a total of 5 YouTube lectures on Chapter 6, didn't I? 2 on atomic radius and ionic radius, and 1 on ionization energies, correct? And then we had 2 reviews, and we added to that electronegativity. Now, on the analytics, I can see how many students watched those. I have almost 40 students, and I had maybe 9 hits on some of those videos. So you do the math. Was it 1 person who viewed them 9 times, or 9 people viewed them once each? I think it's a combination of the 2. Clear? So if you didn't do well, Professor Ahmed, you may want to utilize that resource and some of the other resources that are on my website. Clear? Okay. Because, again, the bad news is Chapter 7 and Chapter 8 are directly dependent on Chapter 6. The good news is you have the winter break in the next few days at least, and some time after the winter break to figure out Chapter 6 if you haven't done so already. Okay? So let's begin. Now, this is what we're going to do. These are the ground rules. They all have books, and they're going to feed me some information about the types of bonding. Now, this is going to be a binary unit. Fancy way of saying 2 chapters. 2 chapters. First one we've done this year where the test is going to be on 2 chapters, Chapter 7 and Chapter 8. That may not seem like a big burden to you, but you have twice the amount of homework. Clear? Okay. So let's get started right away. There are 3 types of bonding that we're going to look at. We're going to look at ionic bonding, and you've had enough biology, maybe some of you haven't, but you're the exception to the rule. Most people have had biology. And in biology, especially if you had Mr. Nair, you're going to find that you had a tremendous amount of bonding and chemistry in biology. Clear? And you know as well as I do that ionic bonding is when you have a transfer of electrons, and covalent bonding is when you have a sharing of electrons. Clear? We also know from biology that bonding is influenced by the electronegativity of the 2 elements involved. If the elements are the same, such as 2 hydrogen atoms, because as you know, hydrogen, oxygen, fluorine, chlorine, and some others, nitrogen, they act as binary compounds, meaning H2, O2, N2, F2, etc. Clear? And when those bonds form, you have a sharing of the 2 electrons. The electrons are equally distributed. So there is a 0 dipole moment, meaning the bond is equally distributed between the 2 elements. Unlike if I have HCl, where 3 is the electronegativity of chlorine. Is that correct? Okay, the electronegativity table, as you remember, is going to be in Chapter 6, a fine resource, Chapter 6. So it would be 3.0 for chlorine. and it's going to be 2.1 for hydrogen. Now, we know that therefore there's going to be an unequal distribution of that cloud because, as you know, electronegativity is an attraction to bonded electrons, correct? Okay, you all right with that, Youssef? You seem a little bit...
No, because I studied it with a different definition.
Okay, well, you may want to consider the definition that you studied it and make the adjustments accordingly. Clear?
Yeah.
Excellent. So, this is going to look like this. You have this one is more. So you have a shift. The dipole is in the direction of the shift. So there exists a dipole, and that these are polar bonds. They are polar bonds. We also remember from biology that you have molecules that have several bonds, such as carbon tetrachloride. And if you looked at the videos on Greek nomenclature, when you have one positive component, written on the left, you call it carbon. When there's only one carbon, you don't say monocarbon. Mono is only used for the right side, for the negative component, such as chlorine in this part, right? Clear? Yes? Okay. So you would say carbon tetrachloride, and you have the dipoles going towards the chlorine, and they balance. They balance. Now, you can see intuitively how they balance here. If you had two sets of vectors mutually perpendicular to one another, it balances. There's no problem with that. Although when we talk about something that you haven't read about, and that is molecular geometry in chapter 8, you will see geometrically how those vectors, how those dipoles cancel each other. Clear? So, we know from biology that you have the opposing dipoles and that you end up with nonpolar compounds, nonpolar molecules, correct? A molecule is something with covalent bonding. Write that down. What's it called when you have ionic bonding? What's one NaCl? A molecule?
It's a salt.
It's a salt, yes, but what's it called? What's the equivalent to a molecule is covalent bonding? What's the equivalent in ionic bonding? A formula unit. NaCl is one formula unit of sodium chloride, correct? One unit of carbon tetrachloride is called a molecule. Molecule covalent bonding, formula unit, ionic bonding. So, this is a nonpolar molecule, correct? If I took one of these off and put in an H, I would have the dipole going that way, and I would have a polar molecule, correct? Now, there's another very, very famous polar molecule that is very unique in the universe. Very unique in the universe. Okay, what is it?
H2O.
Very well done. H2O. And I'm going to show you the importance of molecular geometry, because you know that water from biology (105 degrees, 109.5 degrees). Do you remember that?
Yeah.
We're getting. People are shaking their head. Excellent. Up and down. Okay. And you have unbonded pair here. you have a dipole going here. So you get these lowercase sigma means partial positive charge. Does that make sense? A partial positive charge and a partial negative charge, correct? Yes? Now we'll talk about hydrogen bonding. What is hydrogen bonding? Anybody know from biology? Yes?
Since there's a partial positive and a partial negative,
Correct.
two molecules would tend to stick together because of attraction.
But is that bond chemical or physical?
It's physical.
It's physical, very good.
Because-
This is a chemical bond. That's a chemical bond. A hydrogen bond is an attraction, a physical attraction between the partially negative of the oxygen and a hydrogen. Okay? So you can literally, a hydrogen bond is this. The physical attraction between hydrogen, partially positive charged hydrogen, and an electronegative element. You get it? Physical attraction. But first, we have a guest honor here, a guest of honor, and I'm going to stop the video. We're going to listen to our guest of honor talk about PSATs. She is, when I think of her, I think of wisdom. I think of wisdom. Wisdom.
Okay.
Be right back.
Great. Thank you.
We're filming.
Oh, right. So sorry. I didn't